In this video, we're looking at nuclear energy. So earlier we talked about the different types of energy and how we generate it using generally burning a fossil fuel to generate some sort of steam or heat to turn a turbine. In this case, we can also create electricity with nuclear energy. Nuclear energy is quite different compared to the other types of fossil fuels. Firstly, we don't burn nuclear fuel. It produces its own heat by a natural process called radioactivity. It's really important that you know that concept, that radioactivity is a natural process and it produces its own heat. We're not burning it. Nuclear fuel is packed into long rods which are immersed in water in a nuclear reactor. And this creates steam. So those rods and their radioactivity is what heats the water and produces the steam itself. Nuclear power plants work just like fossil fuel plants, but these nuclear reactors are used instead of the furnaces for producing the heat. Uranium is the most common nuclear fuel. It's a metal, but it's not used in this form. Uranium ore is actually mined, and then it goes through a lot of processes to turn it into the special type of fuel that we need for nuclear power. Firstly, nuclear power, is it renewable? Well, I want you to have a think about it firstly. Post your answer on the class chat before revealing the answer. So pause it here, have a bit of a discussion, post it on the chat on Teams, and feel free to debate with other classmates and their thoughts about it. So did you know that uranium fuel is made into small pellets, each with as much energy as 800 kilograms of coal? In comparison, one train wagon full of uranium fuel is enough to keep a power plant going for a year. A coal-fired power plant needs a whole trainload every single day. So clearly the nuclear power is much more efficient than the coal power. There's two lines of argument to the earlier question. On the one hand, although known uranium deposits only have enough ore to last about 200 years at the rate that we're using it, there is a lot of uranium at lesser concentrations all over the Earth, including in seawater, and we could potentially use this in futuristic nuclear energy systems. On the other hand, a type of nuclear reactor called a breeder reactor produces radioactive material that can be used for further energy. Using these breeder reactors and say uranium from seawater, it's estimated that we could use nuclear power for 5 billion years. That's about as long as the sun will continue to burn. So by that argument, if solar energy is being classed as a renewable because we're using the sun, nuclear power is potentially renewable by the same argument. Now we're going to look at some renewable energy sources. Why is renewable energy important? Burning fossil fuels has multiple problems. On the one hand, fossil fuels are not renewable. We're likely to run out of these in the next 100 years. They damage the environment, and this is from environmental impacts of burning it, mining it, when we have oil spills, and just polluting the air with all of the fumes. They release carbon dioxide, which is a very notorious greenhouse gas. Carbon dioxide traps heat in the atmosphere, and this is the largest contributor to global warming at the moment. Nuclear power doesn't produce air pollution or carbon dioxide, but it does have some other problems. Firstly, the used fuel is dangerously radioactive. It must be buried away safely for over 1,000 years, so we need to find somewhere where we can put this thing. Accidents can happen, unfortunately, and they have happened. You look at Chernobyl as one of the most famous ones. Fukushima had a nuclear disaster after a flood, but Chernobyl is certainly the most popular. If you haven't seen it, there's a HBO miniseries about Chernobyl. It's very factually accurate, quite horrific in some sections, but it's a really powerful documentary about the story of Chernobyl and what led up to it, what happened, and how they dealt with it. All of these are serious issues, but carbon dioxide emissions are generally considered to pose the biggest immediate problem. Because of this, we want to increase our use of renewable energy resources, including solar, wind, and hydropower. For these resources, there is much less carbon dioxide produced. For example, when we talk about solar power and wind power, they don't produce any, and hydropower produces a very small amount. These resources are renewable, so we shouldn't run out of them. And in general, they operate safely and cleanly, producing no pollution. Let's look at solar originally. Our planet receives a lot of solar energy, but we have to capture it in order to use it. One way is using photovoltaic cells, or solar panels as we call it, which convert sunlight directly into electricity.
Renewable Energy 101. Question. What's the most abundant energy source in our solar system? Here's a hint. It's 1 million times bigger than the Earth, and without it, our planet would be a dark, cold rock floating in space. You guessed it, the incredible, brilliant sun. The Earth gets more energy from this ball of fire and gas in one day than the whole world's population uses in an entire year. Every living thing depends on the sun for its existence, from tiny microbes deep in the ocean to plants, animals, and people. Humans have been tinkering with solar energy since the dawn of time. Ancient civilizations used glass and mirrors to light fires, but it wasn't until the 1950s that technology was developed to convert the sun's energy into electricity using photovoltaic cells. Today, solar technology is more efficient and less expensive, and is used all around the globe to create electricity, heat water, cook food, and even power vehicles. Renewable energy.
Other types of solar energy rely on capturing the sun's heat rather than actually using those photovoltaic cells to generate electricity. This is called solar thermal energy, where thermal is referring to heat. The heat can be used directly, for example, to heat water or create steam to turn a turbine and generate electricity, which is what our conventional electricity generation setups are designed to do. And one type of solar thermal electricity plant is shown on the right. So this is the one in Spain. It's a 2,650 large mirrors that are reflecting sunlight to the top of a tower where it's melting salt at 500 degrees. So all of that heat from the sun is being mirrored back to a point, gets the salt very, very hot, it melts, and that molten salt is then used to make steam, which turns a turbine, and that generates electricity. A serious drawback with this, though, is that with all types of solar power, we need sunlight. And depending on where you are in the world, we have night and day. So we can only get a couple of hours or maybe 12 hours at best of sunlight. And it also depends on the cloudy day. So we can't have an entire city running off of solar power and a cloud goes overhead and the whole city blacks out. So that's a big limitation. So here are your different types of solar power. On the left is the most commonly known, the photovoltaic, which takes the sunlight in the solar panel cells, it converts them into electricity directly. Then we've got solar thermal. So the example that we've got here is we've got mirrors that focus it into a point, generates the steam which spins the turbine, turns the generator, we get electricity. We can also have things like this, which is a thermal hot water system. So we've got all these little tubes of water, the sun heats them up, they pass through the pipe out into your shower or your hot water taps or whatever it is. So we're using solar setups there to heat the water directly for use. So we're not generating electricity here, but we're generating the hot water.
Wind is a powerful source of energy on our planet. In fact, many of us have seen it in action, propelling sailboats across open seas or turning the blades of a farm's windmill to grind grain or pump water. Modern wind turbines are basically sleeker, higher-tech versions of the windmills of the past. But instead of using the wind to do farm work, they're designed to convert wind energy into electricity. Here's how it works. Wind blowing across a turbine's blade creates more pressure on one side of the blade than the other. This causes the mechanism of all three connected blades to turn. This rotation pushes on a series of spinning parts inside the body of the turbine, which in turn spins a generator, producing electricity. Because wind is always blowing somewhere across the surface of the Earth, it's considered a renewable resource. And because the only thing required to turn a wind turbine is moving air, wind farms emit no greenhouse gases. However, even though it's clean and abundant, there are a number of reasons we still don't use wind power more widely. The first, and perhaps most important, is that the wind doesn't always blow, at least not always in the same spot, and technologies for storing lots of electricity for later use are currently very expensive. Another problem is location. It doesn't make sense to put wind farms just anywhere. The best sites are open, windy places, which are often far from city centers where energy demand is greatest. So long transmission lines are necessary to move the electricity to where it's needed. Finally, while wind farms are relatively cheap to operate, they cost a lot to build, especially in comparison to existing coal and natural gas power plants. The result is that many wind projects simply never get off the ground. At the moment, wind power makes up only a small portion of the electricity produced in America, but it's a rapidly growing industry that many experts believe could one day slash fossil fuel consumption. And just like solar, it will become cheaper and easier to use if we can find better ways to store the electrical energy it generates.
So you can see from this table here, this shows you the proportion of countries' electricity from wind. Denmark is quite high, so 34% of Denmark's power is generated by wind. And as they said in the video, only 4% of the US is actually produced. However, when you think about the capacity, this is the maximum rate of electrical production, their maximum capacity is actually 61,000 megawatts, even though Denmark's maximum is only 5,000. So there's considerations there that while this is a small percentage of the population, they're actually able to produce more power than Denmark is. But given how much they consume or their population, the percentage actually works out much less. Hydropower uses flowing water to turn a generator, just like the wind power does, except now instead of air blowing through it, we've got some sort of water source. So an advantage is that we can use something like a dam to store the water, and this gives us a more constant supply. By having virtually a giant water tank and we let a small amount through, we can continually push the turbines, and that way we can regulate this water much better. Whereas wind, we have no control over. We can't store wind, and we never know really when it's going to blow and when it's not. There are some arguable disadvantages to hydro and the effect on dams. The key points to take out of this video, which you should be writing down, are cold water and the low oxygen water and the effect that they have.
Most people are aware of the impediments these dams make for spawning and migrating fish. But it's not just that. Water in a reservoir is stagnant, gathering more sediment and growing more aquatic weeds and algae than a river would. That causes problems with downstream life. Fish are used to certain temperatures and levels of oxygen in their river water. Dams not only block the fish from getting where they need to go, but deep reservoirs held by the dam result in dam cold water with very little oxygen. Opening the reservoir to respond to, say, a sudden demand for electricity causes this cold, barely oxygenated water to rush into rivers, suffocating and killing fish. Most people are...
Okay, from here, as per the task, go to the quizzes for renewable energy, complete that, post your score once you're done, and that is the end of today's lesson.